In examining the detail of what exactly happened during those critical 4.5 minutes from pitot blockage to impact with the sea, the timeline can be broken down into 3 distinct phases. Phase 1 relates to the 52-second period from initial autopilot disconnection to just prior to the wing stalling. Phase 2 commences as the aircraft enters the stall and continues through those moments where recovery was most likely possible. And finally, Phase 3 covers the last 3 minutes and 12 seconds of the flight, from the point at which recovery is most probably impossible to the moment of impact. The presentation you're about to see is a factual reconstruction of the accident. This data is compiled from flight data recordings and cockpit voice transcripts released by the BEA, who are the French bureau tasked with responsibility for the investigation of accidents and incidents involving French registered aircraft. In order that you fully appreciate the information being presented, let's just take a moment or two to walk through the display and explain the various observable parameters. The aircraft is obviously depicted mid-screen. Its movements in pitch, roll and yaw exactly reproduce those of the accident aircraft. Despite the fact that the accident occurred during the hours of darkness, the reconstruction depicts daylight in order to maximize the visual understanding of events. Simplified depictions of pilot side stick orders are shown to the left and right, one for each pilot. The current depiction shows both side sticks in the neutral or hands-free position. Think of the display as a plan view looking downwards on the side stick from above. Where a pilot inputs a forward movement on the side stick in order to pitch down and lower the nose, the black dot will correspondingly move upwards on the display towards the top of the screen. Conversely, where an input is made to pitch up or raise the nose, the black dot will correspondingly move downwards on the display towards the bottom of the screen. Or in other words, black dot movement above the horizontal line indicates a pitch down command, while black dot movement below the horizontal line indicates a pitch up command. A roll command instructing the aircraft to turn left will see a corresponding movement of the black dot to the left of the vertical line. Likewise, a roll command instructing the aircraft to turn right will be displayed as the black dot moving to the right of the vertical line. The degree and speed to which the black dot moves away from the central position is indicative of how far and how fast the pilot is moving the side stick. Above the side stick indication is a simplified representation of pilot rudder inputs. Where the pilot inputs left rudder in an effort to yaw the nose of the aircraft to the left, the black horizontal bar will correspondingly move from the center position to the left. The reverse applies should the pilot input right rudder, where the bar will correspondingly move to the right. Again, the rate and magnitude of displacement are indicative of how far and how fast the pilot applies pressure to the rudder pedals. The labels of PF and PNF once again depict the pilot flying, in this case First Officer Bonan, and the pilot not flying, being First Officer Robert. The primary flight displays, or PFD, one in front of each pilot, do exactly as the name suggests, presenting to the pilots the fundamental information needed to fly the aircraft, namely pitch and roll information, what many would have traditionally called the artificial horizon, airspeed, altitude, and vertical speed, indicating the rate at which the aircraft is climbing or descending, expressed in feet per minute. As shown on the right PFD, the lower part of the display presents an indication of heading. The 2 green bars displayed close to the centre of the screen depict the lateral and vertical command bars of the flight director. Across the top of the PFD is placed the FMA, or the flight mode annunciator. As can be seen, this is divided into 5 separate columns. Each section presents specific information to the pilots as to what modes the auto thrust, autopilot and flight director are currently engaged in. Unfortunately, this information is not reproduced here, and unlike the actual aircraft, the FMA remains blanked out throughout the presentation. The only indication which does appear on the FMA is the illumination of the red stall light, which coincides with the stall warning activation. This particular depiction is for display purposes only and is not representative of the real aircraft. That said, the associated illumination of the red master caution lights and the associated oral warnings are representative and true to what the pilots would have experienced. The screen second from the left depicts the various ECAM fault messages and the associated red warning or amber caution light illumination. Also on this screen, and positioned here specifically for presentation purposes only, is a depiction of the THS or the trimmable horizontal stabilizer. From the viewer's perspective, the more the green airfoil graphic is deflected upward, the more nose-up trim is being applied to the aircraft. The third screen from the left represents engine power and thrust lever positioning. The various gates on the thrust lever pedestal are indicated as climb, flex and toga, take off and go around. Finally, the fourth screen from the left depicts angle of attack and G-load information. A word here about the relationship between Mach number and critical angle of attack. Remember, at Mach values of less than 0.3, the critical angle of attack for the most part remains constant. Increase above this value, however, and things begin to change. In summary, due to compressibility issues, as the Mach number increases with altitude, the critical angle of attack value reduces. So for example, a 330 at 10,000 feet maintaining a speed of less than 0.3 Mach might well have a critical angle of attack of about 14 degrees. Take the same aircraft to altitude and cruising at a Mach number of 0.8, and this critical angle of attack would be reduced to about 6 degrees. Essentially, this means that the manoeuvring margin at high altitude are considerably tighter than those at low level. Again, these depictions are purely for presentation purposes only, as angle of attack values are not displayed directly to the crew, while G-loading information, if present, is displayed in such an abstract way as to make the information almost unusable. The first showing of the reconstruction will run uninterrupted for the full 4 minutes and 23 seconds from pitot blockage to final impact with the sea surface. Thereafter, we will methodically analyse the various phases of the accident in order to get a complete and comprehensive understanding of the events.
Stalled. Priority right. Stalled. stall, 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 stall. Dual. Dual input. Dual input. Dual input. Dual input. Stall, 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 stall. Dual input.
Sync rate. Pull up. Pull up. Pull up.
Stall, stall.
Pull up.
Priority right.
Pull up. Pull up. Pull up.
In order to maintain a perspective on aircraft dynamics in relation to time, a graph of altitude, angle of attack, and pitch attitude are continuously depicted on the left-hand side of the screen. Phase 1 commenced at time 0 to 10 and 5 seconds. With blockage of the aircraft's pitot probes, the autopilot disconnected. 2 seconds later, the first prolonged speed drop was noticed on the right-hand speed tape. 1 second after that, the speed indications became abnormal on the left-hand side. Recordings of the left-hand speed input showed a sharp fall from 275 knots to 60 knots. Moments later, a similar dramatic reduction was registered on the standby instrument system. This recorded loss of more than 30 knots in 1 second initiated a process whereby the system began to monitor the difference between the previous mean value and the current indicated erroneous airspeeds for a defined period of 10 seconds. The flight control laws reconfigured from normal law to alternate law 2 as a result, and with no recovery to within 50 knots of the original mean value within this verification period, this reconfiguration became locked in and non-reversible for the remainder of the flight. Since the salience of the speed anomaly was very low compared to that of the autopilot disconnection, it is reasonable to assume that the crew's first awareness of a problem came with the latter and not the former. Although the reason for the disconnection would certainly not have been known to either Bonan or Robert, they reacted with the normal learned reflex action, which was to take over manual control. Undoubtedly, this sudden crescendo of oral and visual stimuli would have resulted in a significant startle effect and emotional shock to both pilots. Within the first 2 seconds, due to the environmental conditions the aircraft found itself in, the bank angle increased to 8 degrees right wing down without any pilot input on the side stick. In response, Bonan announced, "I have the controls," and began manually flying the aircraft with up to 3/4 nose inputs and up to full left roll input being made. Remember, being an alternate law 2, the aircraft will no longer maintain a constant bank angle or wings level by itself. To compound things still further, roll sensitivity in alternate law 2 almost doubled from the maximum allowable 15 degrees per second in normal law up to 25 degrees per second now. From a technical perspective, the location of the 330 static ports below the fuselage midline, forward of the wing, has the tendency to cause a localized overestimation of the actual static pressure, particularly on the 330-200 series aircraft. The magnitude of this overestimate equates to approximately 300 feet in altitude. This is normally nullified by means of a complicated algorithm which relies heavily on Mach number input. Lose the input, in this case as a result of the pitot blockage, and the error remanifests itself in a reduction of indicated altitude. In other words, with the blockage established, the indicated altitude would no longer have indicated 35,000 feet, but rather 34,700, with an instantaneous downward trend visible on the vertical speed indicator of about 700 feet per minute. Was Bonan quick enough to spot this, and if so, was this why he initiated a pitch-up input on the side stick to try and correct this apparent loss of altitude? My own personal opinion is that his understandable difficulty in trying to bring the early roll excursion under control took away from his attention and ability to monitor and comprehend what the aircraft was doing in pitch. Regardless of why the inputs were made, the significant issue is that they were made, setting the aircraft on a trajectory which ultimately sealed the fate of all those on board. The flight directors, although not deselected by the crew, at this point disappear from view. At 0210 and 8 seconds, the autothrust disconnected and defaulted into thrust lock, maintaining the current power setting of 83%. This, through an unfortunate coincidence, was somewhat less than the normal cruise setting, as Bonan had just prior to the disconnection instructed the autothrust to slow the aircraft due to the turbulence they were experiencing at the time. 2 seconds later, at 0210 and 10 seconds, the pitch attitude, due to inputs on the right-hand side stick, rose from a value of 0 degrees to 6 degrees as the vertical speed increased to 1,800 feet per minute and the aircraft began to climb. These pitch inputs, in increasing the loading on the aircraft to 1.6 G, also had the undesirable effect of similarly increasing the angle of attack, thereby reducing the already slender margin to the critical value and consequently triggering the stall warning alert. Simultaneously, as the threshold value which triggers the stall warning is dependent on Mach number in order to reflect the aerodynamic effects of compressibility, the blocking of the pitot probes convinced the system that the aircraft was flying slower than it actually was. This caused the warning threshold to be instantaneously raised from a value of about 5 degrees, which would have been consistent with flight at Mach 0.8, to a much higher threshold value of about 10 degrees, associated with the assumed slower flight at a Mach number of 0.3. The practical effects of this can be heard during the early part of the reconstruction, where the oral stall warning is truncated. In other words, as Bonan loads the aircraft by pulling back on the side stick and increases the angle of attack to the point where the warning is triggered, this simultaneous recomputation of the alert threshold caused the abrupt and sudden silencing of the warning, despite the fact that an aerodynamic stall and loss of controlled flight were now imminent. This graph pictorially represents the relationship between Mach number and the stall warning threshold. At Mach 0.82, the stall warning will be triggered as an angle of attack approaches 4 degrees. With the pitos being blocked, the aircraft now erroneously believes it's flying at 0.3, and for this Mach number, the same stall warning will be triggered only as the aircraft approaches an angle of attack of about 10 degrees. Bonan struggled to regain control over the aircraft's rolling motion, with a series of alternating left and right roll inputs developing to the point where they were exactly out of sync with the side stick lateral commands. As the aircraft rolled to the left, he made large and aggressive inputs to the right and vice versa. With little dampening at high altitude, combined with the excessive roll rates and instability of alternate law 2 around the longitudinal axis, these inputs exaggerated an already bad situation and made it worse. Peak bank angle and opposite lateral side stick inputs each occurred at the same time. Only over the next 30 seconds was the aircraft's roll gradually brought under control. The indicated airspeed on the standby instruments decayed again at 0210 and 13 seconds, and over the next 4 seconds fell from 270 knots to 73. In theory, the identification of the failure is mainly up to the PNF, and begins once the flight path is stabilised. In this instance, identification by rub air began while the flight path may have appeared to have been controlled, but one couldn't say stabilised. The crew nonetheless built an initial mental representation of the situation about 10 seconds after autopilot disconnection, based on the identification of a speed indication anomaly. The loss of speed indication was called out almost instantaneously by both pilots. However, their call-outs are not convincing that they fully comprehended the situation. When Robert stated, "We've lost the speed," he could have been referring to the speed display in its entirety, or simply some of the computer-generated symbology on the display. Likewise, Bonan's comment, "We haven't got a good display of speed," may well have been prompted by the triggering of the initial stall warning, which undoubtedly would have drawn his attention to the speed display in front of him through the association between stall and the speed parameter. If the crew had fully comprehended the failure situation they were faced with, the loss of speed information could have prompted implementation of the QRH checklist for flight with unreliable speed indication, had they considered the safe conduct of the flight had been dangerously affected. However, as the procedure leans heavily towards controlling a dynamic flight path in order to avoid collision with terrain, from examination it appears that crews generally are less likely to associate it with a loss of speed scenario during cruise, which may explain their observed reluctance to implement it during this particular phase of flight. Having identified the loss of airspeed, Robert turned his attention to the ECAM, undoubtedly in an attempt to refine his diagnosis and to study any remedial action it proposed. He started to read warnings and consequently called out the loss of autothrust and the reconfiguration to alternate law. The successive display of different messages probably added to the confusion experienced by the crew in its analysis and management. The first indication of system abnormality was the generation of the Level 3 warning, Autoflight, Autopilot Off. This was prioritised as being the most important action for the crew to address, as automatic control of the aircraft's flight trajectory had been lost. Although the crew remained unaware as to the exact reason for the disconnection, the intensity of the ice pellets through which the aircraft was flying had acted to block the pitot tubes on the left-hand side of the aircraft. This had the immediate effect of causing the speed output from Air Data Reference Unit number 1 or ADR1 to drop by more than 30 knots within a 1-second time frame, triggering the pitot probe monitoring by the primary flight control computer and ultimately the reconfiguration of control laws to alternate law 2. The red attention-getting master warning lights illuminated on the glare shield in front of each pilot, with the simultaneous activation of the oral warning. The most natural way for either pilot to extinguish both the visual and oral warnings is to press once the autopilot disengagement push button atop either side stick, or to physically depress either of the master warning lights themselves. The ECAM display, however, remains in view until such time as the PNF, in line with ECAM protocol, acknowledges the failure indication, takes appropriate corrective action if necessary, and subsequently clears the failure from view by depressing either of the relevant ECAM panel clear keys. The reconfiguration to alternate law subsequently triggers the Level 2 caution 3 seconds later of Flight Control Alternate Law. Note that although ECAM does acknowledge the reconfiguration to alternate law, the design of the system does not articulate which alternate law we find ourselves in, 1 or 2. Remember, although the crew are notified that protections have now been lost, assuming that cockpit workload management will allow for normal ECAM protocols to be implemented, the crew are quite ignorant as to whether in the absence of protections, stabilities have been introduced in their place. Alternate Law 1 will provide stabilities and a modest effort to protect the aircraft, specifically in the context of high angles of attack. Alternate Law 2, on the other hand, specifically with ADR difficulties, as was the case with 447, will not. Essentially meaning that inadvertent entry into the stall is now possible with no resistance being offered from the aircraft. During the 3-second window between 0210.07 and 0210.10, the speed output from ADR3 fell temporarily, causing the loss of autothrust and the disappearance of the flight directors. The autothrust failure message is also prioritised as a Level 2 caution. However, as it requires some remedial action on the part of the crew, it immediately replaces the alternate law memo as the second most important action for the crew to perform, following their management of the autopilot disengagement condition. with the result that the alternate law information memo is now pushed further down the priority list into third place. The auto thrust off message instructs the crew to move the thrust levers. This because with loss of auto thrust, the engine power will be deliberately frozen at the current setting in order to eliminate the possibility of unwanted or unexpected thrust changes. This remains the case until such time as the pilots deliberately move the thrust levers, thus regaining manual control of the system. Specific to this failure condition, the single oral chime generated with the failure message is repeated every 5 seconds, prompting the pilots to take this necessary corrective action. The engine thrust locked caution simply re-emphasises the frozen thrust condition. The auto-flight memo on the right-hand side of the screen and the resultant green arrow at the bottom indicate that the display limitations have been reached and we have entered an overflow situation. Essentially, there are more ECAM procedures to be reviewed than can be physically displayed at the current time. Only by the crew systematically working their way down through the list and dealing with those items which are no longer relevant will sufficient room be made available for these overflow items to be viewed. In the absence of a specific message expressing detection of unreliable airspeed, the crew were unable to identify any logical link between the symptoms perceived and the displayed messages. This lack of a clear ECAM diagnosis would have made it particularly difficult for the crew to embrace any one specific procedure or overall common denominator. Robert turned on the wing anti-ice after reading the ECAM, which suggested that at this point he may have considered there was a severe icing problem. The sound of ice crystals hitting the windshield may have supported this perception of an associated risk. The symptoms perceived by the crew may therefore have been considered as further anomalies to add to the anomaly of the airspeed indications, and thus indicative perhaps of a much more complex overall problem. After reading the ECAM messages, which provided no apparent assistance to the crew, Robert directed his attention for a full 12 seconds to monitoring Bonan's control of the flight path. Not having been previously disengaged by the crew, the flight directors now reappeared, directing a return to the initial cruise level of flight level 350 or 35,000 feet. The aircraft's pitch, however, continued to increase through 11 degrees, with the vertical speed increasing through 6,000 feet per minute, as the flight directors disappeared once again. Such performance at high altitude is completely inappropriate and totally unsustainable. The thrust lock condition was deactivated incorrectly by Bonan pressing the auto thrust disconnect button on the thrust lever, rather than physically moving the thrust levers themselves, as was instructed by ECAM. The effect was to cause the actual engine thrust to increase as the levers themselves remained in the climb detent. While engine power application would have been welcomed to address the reducing energy state, slung under the wing as they are in the 330, this increase in power would only have generated a thrust vector which would have acted to pitch the nose up further and thus increase the angle of attack. The result of Bonan's actions are visible on the ECAM, with the thrust lock caution being removed from view. The auto thrust off memo, however, remains in view as a statement of fact that the auto thrust is indeed unserviceable, and as a testament to the fact that cockpit workload is preventing correct ECAM protocol from being implemented. 21 seconds after autopilot disconnection, and the vertical speed reached a maximum value of 6,900 feet per minute as the aircraft climbed through 36,000 feet with a pitch attitude of 12 degrees. A second later, the flight directors appeared again. This time, however, when they reappeared, the previous pitch and roll commands had been dumped, for want of a better expression, and now showed the instantaneous values for the current heading and vertical speed, which at the time was 6,000 feet per minute. Robert in the left-hand seat instructed Bonan to watch your speed. Bonan in turn acknowledged and replied, Okay, I'm going back down. Some nose-down inputs were made, pitch reduced slightly and thrust was also reduced, but in truth the pitch attitude remained well above normal and the aircraft continued to climb. Robert, being more aware of the aircraft's predicament, again instructed Bonan to go back down. According to that, we're going up, so go back down. Bonan simply replied, Okay, as Robert became more and more anxious. You're at, go back down. 27 seconds after the autopilot had disconnected, the pitch attitude was reduced to about 10 degrees, and likewise the vertical speed reduced to about 4,000 feet per minute, as the aircraft climbed through 37,000 feet, 2,000 above its initial level. The angle of attack, typically at 2.5 degrees for cruise, had so far remained below 4 degrees. This was largely due to the vertical inertia of the climb. However, as the inertia predictably depleted, it would require thrust in order to compensate and maintain the established trajectory, and that they didn't have. Jet engines suffer a reduction in maximum thrust output with increase in altitude, and 447 had reached its limit. Shortly, the laws of physics would intervene. Having been on for 9 seconds, the flight directors again disappeared. It would appear by now, some 31 seconds after autopilot disconnection, that the blockage of the captain's pitot tubes had cleared, and airspeed on the left-hand PFD was shown correct at 223 knots, indicating some 50 knots of airspeed had been lost in the climb. Since no clear procedure had been displayed on ECAM to immediately facilitate the crew's dealing with the problem, Robert took the unilateral decision to set the air data selector to first officer on 3. Out of desperation, he was beginning to improvise a solution to their problem, and hoped that this selection would shift the speed information on the right-hand PFD to the alternate number 3 backup source. He also actuated the attitude heading rotary switch and called out his action. "I'm putting you in at." Again, his intention was to replace the pitch, roll and heading information on the right-hand PFD with information from the alternative number 3 backup source. This change of inertial source, which in hindsight was unnecessary, may well have indicated that his diagnosis of the failure was not completely defined. It is one of the many examples where teamwork, problem solving and decision making between the two pilots had effectively broken down. As bad luck would have it, this change of inertial and speed source resulted in the involuntary lengthening of the invalidity of the speed display on the right hand side, where the speed sense from the original source ADR2 was just about to become valid again. After changing the reference source to the backup number 3, Robert's surprised reaction of "What is that?" appears to indicate total incomprehension when presented with the results of his action, since the speed display on the right-hand PFD was still erroneous, owing to the invalid output from the backup source as well. He appeared at this point to be completely overwhelmed, and attempting to summon help from the captain became his top priority. At 02:10:42, the flight directors appeared for a split second, then disappeared again, momentarily providing guidance to maintain the current rate of climb of 1,400 feet per minute. 5 seconds later, the flight directors again reappeared for a more prolonged period of 53 seconds, with the guidance again to maintain the current vertical speed of 1,400 feet per minute. Curiously, Bonan reduced thrust to a considerably lower value of 85%. Was this in response to the thrust increase caused by his incorrect management of the thrust lock condition 24 seconds earlier? Was he starting to believe that they were maybe accelerating towards an overspeed condition? Or was it simply an attempt to initiate a descent as had been called for by Robert earlier? Attempts were made to call the captain back to the cockpit using the call chime that activates in the rest area. Since autopilot disconnection 45 seconds ago, the ECAM has generated a series of warning and caution messages which have been continuously fed to the crew as they continue to struggle with an extremely dynamic flight trajectory. All this time since its reappearance, the flight director has been goading Bonan to maintain a vertical speed of 1,400 feet per minute. Whether he attempted to or not can't be said with any certainty. However, there is some proof to suggest its false promise of guidance to a safer place was too much for Bonan to ignore, and this influence could have caused him to blindly follow their direction without validating the commands they presented. This data compiled from the aircraft's flight data recorder shows the flight director guidance in green. Notice how Bonan's side stick inputs in amber generally act to follow the flight director commands as they periodically reappear into view. Bonan continued to make nose-up inputs and pitch attitude increased to 16 degrees. My earlier suggestion that sooner or later the laws of physics would intervene happened now, 46 seconds after the initial autopilot disconnection. The aircraft no longer had the energy to maintain the flight director target vertical speed. Up to this point, as can be clearly seen in the video reconstruction, the reducing energy state, which would, in any conventional aircraft, have caused the nose to drop, was compensated for and in fact prevented by the horizontal stabilizer trimming continuously to keep the nose up. This was done for no other reason than to satisfy the primary objective of alternate law pitch logic, that being the maintenance of the selected vertical trajectory in 1G flight. At this point, the aircraft begins its departure from the flight envelope. It commenced a gentle descent at first, as it transitioned away from the initial climb trajectory. The software logic having been defeated, the laws of physics now took over. A series of small roll movements began, which Bonan attempted to correct with lateral side stick inputs. The aircraft began to follow a parabolic curve through the atmosphere, still moving forward, while at the same time commencing descent, with the nose held high due to the previous efforts of the horizontal stabilizer. Indeed, at this point the stabilities normally associated with alternate law should have been triggered. The aircraft, sensing the excessive angle of attack condition, should have intervened and made some effort to save itself. However, one of the conditions which inhibits the activation of such stabilities is the loss of or disagreement between two or more ADRs, which due to the pitot blockage is exactly the predicament 447 found itself in. The relative airflow across the wing began to change direction, and for the second time the stall warning was triggered, this time remaining on continuously for the next 45 seconds. The angle of attack had reached 5 degrees, meaning that the remaining margin to the critical angle of attack, at which point the wing would stall, had now become negligible. With the commencement of Phase 2, the time is now 02:10 and 50 seconds, 3 minutes and 38 seconds to impact. As the aircraft approached the stall, the aural alerts in the cockpit became overwhelming. Prior to this, the continuous sounding of the constant sea chime was a warning to the pilots that they had deviated from their initial assigned altitude. A simple pressing of the master caution light on the forward glare shield would have silenced this alert, but that was never actioned by the crew. Furthermore, with initiation of the stall warning, now for the second time, the crew again failed to silence this aural warning, and it continued to enunciate in the background for a prolonged period of time. These apparent inactions on the part of the crew are anything but. Rather, they draw attention to how the human mind works under situations of extreme stress. In truth, what the crew are experiencing is scientifically termed inattention deafness. In simple terms, their cognitive ability to reason what was actually happening to them had started to shut down. Their brains were now in survival mode, where visual stimuli were now being prioritized over oral ones. They simply weren't hearing the aural alerts anymore. Cockpit voice recordings verify that neither pilot verbally identified the stall condition or the onset of buffet as the aircraft approached the critical angle of attack. Numb to the aural environment around them, it is plausible that neither Robert or Bonan was aware that the aircraft had arrived at such a critical juncture, and that the unthinkable was about to happen. As the critical angle of attack was reached, the characteristic deterrent buffet caused by the airflow separating from the wing became more and more pronounced. At this point, only descent through a nose-down input on the side stick would have made it possible for the aircraft to remain within the flight envelope. This depiction of information gathered from the flight data recorder indicates a marked increase in magnitude of buffet from shortly after activation of the stall warning. Perhaps something was triggered in Bonan. He advanced the thrust levers to Toga, the setting which would provide the maximum amount of power available. However, the extreme angle of attack was generating so much drag combined with the limited power reserves available that any further acceleration was impossible. More importantly though, and critical to any possible recovery, was the absence of any forward input on the side stick. On the contrary, nose-up inputs persisted, and for the moment inertia alone resulted in the aircraft continuing with a very shallow climb. The angle of attack had now reached 10 degrees. But if something had been triggered in Bonan, what was it? 10 seconds earlier, he had reduced engine power by a considerable amount. Confused by the onset of Buffet and entertaining the possibility that he had subconsciously acknowledged activation of the oral stall warning, had he simply been spooked into undoing his previous actions? Application of power could be considered consistent with stall recovery training at the time, where erroneously a considerable emphasis was placed on powering through the stall, with only modest associated change in pitch and a false preoccupation with minimising altitude loss. Indeed, if it was an effort on Bonan's part to initiate a recovery from the stall, some have speculated that the half-hearted effort may have been the result of misgivings on his part as to the authenticity of the warning. The transient activations of the warning after the autopilot disconnected may have caused him to doubt its credibility. Furthermore, the fact that the flight director was advising a nose-up pitch attitude may have only served to confirm his belief that the stall warning was not relevant. Of significant importance is the fact that the flight director in the 330 does not feature any stall avoidance logic and will not provide any visual guidance to a pilot on where to position the aircraft in order to effect a successful recovery from such situations. A few seconds after the application of power, Bonan said, "I'm in toga, right?" Either he was unsure whether or not he had actually positioned the thrust levers in the correct detent, or he didn't understand why his actions had not been effective in clearing the stall warning. The latter would confirm that Bonan had built an erroneous mental representation of the aircraft's flight path, whereby power and an adopted pitch attitude of about 12 degrees, something akin to guidance in the unreliable airspeed checklist for recovery at low altitude, would similarly work here, but it hadn't. And why would it? This was now a much more serious situation than simply a loss of indicated airspeed. The aircraft was now in a stall, uncontrolled flight, and the recovery procedure for that is fundamentally different. Finally, although in hindsight there were visual indications which Bonan could have assimilated to identify that the aircraft had reconfigured into alternate law, in truth had he? From personal experience, Airbus at the time blindly believe in their product's reliability, and more than once on both my 320 and 330 conversion courses, I was told that an Airbus simply can't stall. If this was his abiding memory of Airbus training, then conceivably this also reinforced his potential bias that the stall warning was inconsistent and worthy of some skepticism. At 0211, Robert again offered advice from the left-hand seat. "Above all, try to touch the lateral controls as little as possible, This comment reinforces the belief that neither pilot had comprehension of where the aircraft was and where it was about to go. If Robert had had an understanding of what was happening, and he had been able to fully comprehend the developing flight path, it would have been inconceivable that his primary concern would have been the aircraft's rolling motion. As is the case with most aircraft, uncontrollable roll is often symptomatic of an aerodynamic stall. A stall can only be rectified by reducing, first and foremost, the angle of attack to below the critical value. You need to reattach the airflow to the wing, and that's all about pitch. Addressing the roll is secondary. As the stall developed, these roll oscillations intensified. 9 degrees to the right, 16 degrees to the left. Fighting to remain in control, Bonan's inputs on the side stick became more exaggerated and aggressive in response, using up to full deflection in both directions in an effort to stay on top of the situation. Through the early part of the descent, with the air data switching still selected to First Officer on 3, speed indications on the right-hand PFD would still have been showing data from the backup source. At this time, it would appear that the probes associated with ADR3 unfroze and began to display a valid airspeed again. The airspeed indications on the standby instruments, and presumably likewise on the First Officer speed tape, although not actually recorded, increased from 129 knots to 183. This sudden increase in indicated value would have caused a transitory phenomenon whereby the trend arrow on the respective speed tape could have suggested to Bonan that a considerable acceleration was underway. In the absence of any speed source which he could conclusively say was true, it is plausible that Bonan could have actually entertained the possibility that the aircraft was about to overspeed. Certainly there were indications present which he may have associated with such a threat. His application of toga power, and specifically the presence of aerodynamic buffeting. Unbeknown to most A330 pilots on the line at the time, however, is the fact that the supercritical profile of the 330 wing does not display this buffeting characteristic at high speed, only at extremely low speed while approaching the critical angle of attack. Furthermore, he would have associated normal cruise Mach numbers as having a narrower margin to the upper or overspeed end of the speed tape compared to the lower, slower end. Did misinterpretation of these cues have a bearing on his diagnosis of the problem? Again, who knows? However, if this was the case, it might go some way to explaining why he continued to make pitch-up inputs, which would have been consistent with trying to manually prevent or correct just such a potential overspeed event. As a side note, the fact that even now, years after the accident, both hypotheses are promoted, the perception of overspeed or underspeed, highlights the considerable ambiguity which still exists in relation to the crew's level of situational awareness, and the subsequent impact this undoubtedly had on their decision-making and problem-solving abilities. In truth, the initial surprise and startle associated with the loss of automation and instrumentation left the crew so stunned that they could never really come to grips with their rapidly changing environment. As a result, without any proactive correction, the angle of attack continued to increase, and by now had reached 14 degrees. At 0 to 11 in 10 seconds, the maximum altitude of 37,924 feet was reached. Kinetic energy had been completely depleted, and as 447's chaotic climb came to its conclusion, the vertical speed dwindled to 0, and all 200 plus tons of the 330 gently transitioned into its terminal descent towards the Atlantic below. As its descent commenced, 447's impact with the sea was now just over 3 minutes away. The aircraft had gained almost 3,000 feet in altitude and lost almost 90 knots in airspeed in the 1 minute and 7 seconds since autopilot disconnection. 10 seconds later, with the stall warning still sounding, Robert stated, "But we've still got the engines, what's happening?" The crew's management of the situation, arguably poor from the outset, appeared now to be completely gone. Neither pilot was capable of rationalising what was happening to the aircraft. With continued back pressure being applied by Bonan to the side stick, the angle of attack had now reached 20 degrees. In truth, the effort which would have been required at this stage to unstall the wing would have been considerable, and would have required a prolonged pitch-down input of such magnitude as to have been completely unrepresentative of stall recovery training at the time. In discussions with Airbus test pilots since the accident, the question often arises as to when recovery would no longer have been possible. Recovery from 14 degrees angle of attack had previously been demonstrated at low level, albeit under strictly controlled conditions. However, this wasn't low level, and 447 had achieved an angle of attack significantly greater than 14 degrees, with no effort being made to correct the situation. So this was uncharted territory, and no one had ever taken a 330 this far outside of the normal flight envelope before. In private, however, those same test pilots conceded that even as the aircraft descended through 37,000 feet, with such an extreme angle of attack which was only increasing in value, there most probably wasn't enough altitude below the aircraft to effect a recovery, and that loss of the aircraft, even at this stage, was most probably inevitable. With descent, nose-up inputs were maintained and the aircraft started to bank consistently to the right. Left inputs were made which slowed the rolling motion for a few seconds. Robert again asked, "Do you understand what's happening or not?" The bank angle increased to the right, reaching a maximum of 30 degrees. Bonan held full left stick with virtually no effect. From this point, the protracted right-hand turn was continued through a total of 225 degrees before the final impact with the sea. Bonan stated, "I don't have control of the airplane anymore. I don't have control of the airplane at all." This image shows the final track of Flight 447 from its initial divergence off course for weather avoidance through its protracted 225-degree turn to the right, following its stall and departure from controlled flight. In a desperate bid to see if he could influence what was happening, Robert said, "Controls to the left," meaning that it was his intention to now become the pilot flying and that Bonan should relinquish control. He made 2 brief full left control inputs in an effort to stop the roll to the right, then released his side stick to the neutral position. Bonan had, however, not relinquished control. Instead, he had continued to hold his side stick full aft and to the left for a period of 40 seconds. On this occasion, Robert's inputs were of such a short duration that the dual input warning was not triggered. The angle of attack had now exceeded 30 degrees and was still increasing. Pitch values fluctuated between 10 and 16 degrees as the rate of descent increased to 10,000 feet per minute. The aircraft was essentially in freefall. At 02:11 and 42 seconds, Captain Dubois returned to the cockpit. Bonan and Robert had been struggling with the aircraft now for the last 1 minute and 37 seconds since autopilot disconnection. What he saw was totally bewildering. The aircraft was pitched significantly more nose up than he would have ever seen before in cruise flight. It was in a bank turn to the right, approaching 45 degrees, with a rate of descent which may not even have been presentable on the vertical speed indicator, but coincidentally still relatively close to the 35,000 feet assigned altitude he last witnessed before leaving the cockpit for his break. Significantly, what might have given the game away was the oral stall warning, but coincidentally it had silenced just as Dubois had entered the cockpit. The reason why the warning had suddenly silenced would suggest that the angle of attack had reduced below the critical value. However, in reality, nothing could have been further from the truth. In simple terms, in order to generate a valid indication of airspeed, the static pressure value measured at the static ports is subtracted from the total pressure source sensed by the pitot probes. This total pressure is the sum of the dynamic pressure, we'll call it PD, sensed by the aircraft as it moves through the atmosphere, and the static pressure, which we'll call PS, of the undisturbed atmosphere surrounding the aircraft. The differential between the two is a measure of resultant dynamic pressure alone, the magnitude of which relates to the indicated airspeed of the aircraft, or IAS. What was only brought to light in the subsequent investigation was the fact that, at extreme angles of attack, the respective locations of both the pitot probes and static ports meant that more dynamic pressure was actually being sensed by the static ports than was being sensed by the pitot probes. The implication here is that as pressure in the static ports increased, simultaneously the total pressure being sensed at the pitot ports was decreasing. The resultant dynamic pressure, and thus indicated airspeed, was therefore shown to decrease with increasing angle of attack. As this indicated airspeed reduced through 60 knots, the angle of attack values of all 3 ADRs was rendered invalid per system design, and the stall warning was thus silenced. Further increase in angle of attack to the point where the indicated speed registers less than 30 knots, and the speed tape indications are withdrawn from view on the PFD. Where the angle of attack to be reduced, the anomaly works in reverse. As the IAS increases to a value equivalent to 30 knots or more, the speed tape will reappear. Further reduction in angle of attack and a resultant increase in IAS to 60 knots or more will revalidate the stall warning. Dubois asked, "What the hell are you doing?" Robert replied, "What's happening? I don't know. I don't know what's happening." Bonan added, "We're losing control of the airplane." To which Robert added further, "We lost all control of the airplane. We don't understand anything. We've tried everything." Neither Bonan or Robert informed Dubois of the fact that they had climbed to almost 38,000 feet and were actually now on the way back down. Dubois positioned himself in the centre jump seat at the rear of the cockpit, behind and between the 2 first officers, and remained in this location for the remainder of the flight. The pitch attitude porpoised between 8 and 15 degrees nose up. The thrust levers were moved to idle, and despite the full backstick inputs by Bonan, This reduction in the thrust vector resulted in the nose pitching down to about 11 degrees below the horizon. Traditional stall recovery training at the time would have suggested that at such pitch attitudes, a recovery should have occurred. However, the reality of the situation was that even with such a nose-down attitude, dramatic under any circumstances, the angle of attack never fell below 35 degrees, still about 30 degrees higher than would have been necessary to install the wing. Engine power decreased to 58% over the next 20 seconds, while the rate of descent increased to 15,000 feet per minute. This reduction in pitch attitude, although doing nothing to install the wing, did reduce the angle of attack sufficiently to allow the computed airspeed to increase above the 30 and 60 knot thresholds, causing both the speed tape information to be displayed once again and the stall warning to be reactivated. The crew are now faced with a completely counterintuitive situation. As the pitch attitude increases, the stall warning silences. As the pitch attitude decreases, the stall warning is triggered. One can only imagine that any previous skepticism the crew had in relation to the validity of the stall warning must now have only been reinforced. Perhaps this was the reason that Bonan subsequently said, "I have the impression that we have some crazy speed, no? What do you think?" What exactly did he mean by crazy? If he had reservations about the validity of the stall warning, perhaps he suspected some crazy fast speed rather than some crazy slow one. This would certainly explain his next action. He reached over and deployed the speed brakes. These are large hydraulically activated panels on the upper surface of the wing, designed to protrude into the airflow, increasing the resultant drag to either help with deceleration and or lift dumping in order to increase the rate of descent. The aerodynamic effect of extending the speed brakes caused the nose to pitch up, thus compounding their angle of attack problem. An inconceivable act if you were aware that the wing was actually stalled. Robert, although not any more convincing in his understanding of the predicament, was perhaps a little bit more cautious and instructed Bonan to restow them again. Such action, though, was not instantaneous on the A330 and would have taken a considerable number of seconds to complete. As they stowed, the nose again dropped to initially 8 degrees below the horizon and subsequently began to oscillate between this value and 15 degrees nose up. The aircraft continued to descend with vertical speeds of between 10,000 and 15,000 feet per minute. The counterintuitive oral warnings and speed indications continued to cycle on and off. As pitch increased, they lost speed indications and stall warning. As pitch decreased, both returned. The bank angle rocked between 20 and 40 degrees to the right as the turn in that direction continued, accompanied by corresponding yaw motions and back and forth lateral accelerations. Both pilots and the automatic yaw damper fought to keep the aircraft upright, avoiding the possibility of entry into a spin. The thrust levers were positioned to the climb detent and power increased from 58% to 105 within the next 10 seconds. Shortly after, Bonan momentarily depressed his side stick takeover push button, generating the priority right synthetic voice warning, although there had been no attempt by Robert at this stage to interfere with what he was doing. The depressing of the takeover push button can most probably be explained as an involuntary act on his part. As the speed tape on the left-hand PFD blanked, Robert once again reselected the ADR reference source. This time again improvising a potential solution to the display problems, he selected air data to Captain on 3, in the hope that the alternative source of information would restore a speed display on his instruments. For the first time in a minute, the bank angle passed through wings level as it oscillated left and right, with Bonan making large side-stick deflections to counter every roll action. Again, devoid of any clear reasoning, the thrust levers were moved from the climb detent to toga. Descending through 20,000 feet, the aircraft began to roll to the right once more, with the bank angle exceeding 40 degrees within a few seconds. To counteract, Bonan again applied full left side stick and held the input steady for a constant 20 seconds. Despite the ECAM procedures not having been completed by this specific timestamp at 02:12 and 44 seconds, it is nonetheless significant in that it is the first time the aircraft's diagnostic system has presented an explanation as to why the autopilot had initially disengaged, with the rejection of ADR 1 and 2 some 2 minutes and 39 seconds beforehand. At this point, however, the aircraft was descending through 20,000 feet, stalled, with an angle of attack in excess of 41 degrees, a condition which in all likelihood has been unrecoverable for some time. Some commentators have alluded to the fact that the slow display of the ADR disagree message may have in some way compromised the crew's ability to comprehend the root cause of their problem. However, I disagree. From examination, it appears that the crew never really interacted with the ECAM, other than in a coincidental, non-deliberate manner by random and arbitrary movement of the thrust levers. I say this with confidence, as the autopilot off message, once triggered, remains displayed until impact, clearly demonstrating that there was no conscious effort on the crew's part to cancel any warnings or cautions through the normal means. Furthermore, the cockpit voice recorder transcripts clearly indicate that the crew were aware of lost airspeed indications from an early stage, with the first verbal reference made at 02:10 and 14, 9 seconds after autopilot disengagement. At 02:12:44, with display of the ADR disagree message, the ECAM display remained unchanged until impact. As the aircraft descended through 10,000 feet, Bonan reacted by calling out, "We're there, we're passing level 100. In just 2 minutes and 8 seconds, the aircraft had fallen 28,000 feet. Robert said, "Wait, me, I have the controls." He made a left input for about 7 seconds, but Bonan never released his side stick, causing the synthetic voice to call out, "Dual input," meaning that contrary to Airbus design philosophies, both pilots were now attempting to fly the aircraft at the same time. The confusion continued. Bonan once again queried, "How come we're continuing to go down now?" Robert, still desperately looking for a solution, instructed Dubois to see if a reset of the flight control computers would help. The captain was unconvinced that they would, but reset Prim 1 and Sec 1 nonetheless. Bonan called out, 9,000 feet! His side stick was still about halfway back. The elevator and stabilizer were full nose up in a futile effort to deliver on his flight path demands, and thrust levers continued to deliver toga thrust. Their desperation became more and more apparent as Robert called out, "Climb, climb, climb, climb!" To which Bonan replied with the now infamous words, "But I've been at max nose up for a while." Like a light bulb suddenly being switched on in a dark room, Robert pushed his side stick all the way forward for a full 5 seconds as the dual input warning sounded again. Dubois in unison shouted, "No, no, no, don't climb!" Pushing his side stick forward again, Robert's instructions mirrored those of the captain. "So go down!" as the thrust levers were pulled back to climb power. Bonan, however, never eased up on his inputs and continued to pull back, triggering the dual input warning for the 3rd time. Robert commanded Bonan to give me the controls to me, controls to me. This time Bonan relinquished and acknowledged, "Go ahead, you have the controls. We're still in toga." Robert lowered the nose to 7 degrees below the horizon, and both the airspeed and the stall warning returned. Despite having acknowledged transfer of handling duties to Robert, Bonan again inexplicably began to pull back on his side stick. As Robert had not pressed and held the override push button on his side stick to completely lock out any inputs from Bonan's side, their combined inputs were added, once again causing the aircraft's nose to start pitching up. As the aircraft passed through 5,000 feet, it transmitted automatically the last of 24 ACARS messages, the first of which had been initiated with the initial disconnection of the autopilot. These messages relaying the technical health of the aircraft were transmitted to Air France's maintenance facility in Paris. Unlike telemetry information, these messages simply indicate that maintenance action is required on a particular system or subcomponent within the system, without specifying the cause of the actual defect. As such, this stream of information by its very nature is imprecise to the extent that it cannot, nor should it be, used for incident or accident analysis. However, in the immediate aftermath of the accident, these were the only clues available as to what had happened to 447. With this last transmission, a message was sent indicating that the rate of cabin altitude change had exceeded 1800 feet per minute for a period of time in excess of 5 seconds. Some analysis initially believed that this was the result of an in-flight breakup. However, what subsequently transpired was that the aircraft descending in excess of 10,000 feet per minute had physically descended below the altitude of the cabin, which was descending at a much slower rate of about 300 feet per minute. At this point, the door seals, no longer pressurized from within the cabin, had released and allowed air to enter the cabin from around each door. In addition, the negative pressure relief valve had also opened in order to facilitate pressure equalization between the environments inside and outside of the aircraft. From this point until impact, the cabin would have descended at the same rate as the aircraft, namely in excess of 10,000 feet per minute, hence the triggering of the associated message. One can only assume that in the absence of any improvement in their predicament, Robert was forced to re-evaluate. He pulled back on the side stick and added, I'm pitching up. The thrust levers were retarded to idle for 2 seconds and the nose pitched up to reach 16 degrees. Dubois again warned, you're pitching up, to which Bonan replied, well, we need to, we're at 4,000. At 02:14 and 16 seconds, as the aircraft passed 2,500 feet and descending at almost 11,000 feet per minute, the ground proximity warning system became aware of the ocean surface rapidly approaching from beneath. Sink rate, pull up. The captain gave permission. Go on, pull. And Bonan, in one final act of desperation, called, let's go, pull up, pull up, pull up. The thrust levers were moved to toga, and a nose-up command was applied by both pilots simultaneously as the aircraft again pitched to 16 degrees nose-up. In the final few seconds of their fall, Bonan pushed the takeover push button on his side stick, cutting out Robert's commands. For the last time, the synthetic voice called out, priority right, meaning that Bonan alone had control over inputs to the flight control computers. Still with no clear understanding of what was happening to the aircraft, Bonan exclaimed, we're going to crash. The stall warning again sounded. Stall, stall. The GPWS again commanded, pull up. This can't be true, said Bonan. The GPWS again commanded, pull up, as Bonan's final words revealed his still total and complete lack of comprehension. But what's happening? Dubois commanded, 10 degrees pitch attitude, while the GPWS still continued in the same vein. Robert pushed his side stick forward one last time, but Bonan was still pressing his takeover push button while continuing to pull hard back. Robert's locked out inputs had no effect, nor could they. The opportunity to recover had vanished a long time ago. Recording stopped at time 02:14 and 28 seconds UTC, 3 hours and 45 minutes after departure from Rio de Janeiro, and a mere 4 minutes and 23 seconds since the autopilot disconnected due to blockage of the aircraft's pitot probes. Flight 447 impacted the Atlantic Ocean at almost a 45-degree angle, with the nose stubbornly held high at 16 degrees. The aircraft entered the water with a roll attitude of 5 degrees to the left, a forward ground speed of 107 knots, the equivalent of 198 kilometers per hour, and a final rate of descent equivalent to 10,900 feet per minute. For the majority of the descent, the angle of attack never reduced below 35 degrees. The impact was unsurvivable, resulting in the loss of all 228 souls on board.